Good morning.
Hello, welcome.
Can you already hear us? Just write in the chat. So I think maybe they are still connecting a bit. So there's a kind of a latency between the camera and the sound to actually work. So if you can actually hear us, write us a message.
Okay, perfect.
All right, perfect. So we got sound. So welcome to our second webinar. Actually, it's still the first, but in English now. And it's about the Cooltrol Data, a new controller that we developed. It's not actually new, but it's different to our old controllers. So let's start right into the topic.
Okay. There we go.
Right. So for today, we're just doing a short introduction to ourselves, to me personally, and also Birgit. And then we will talk about cooling systems, how they actually work, what is inside processes, what is relevant, and also afterwards then the technique we are using, the blowdown controllers for the cooling systems. Then the new Cooltrol data, what is new, what is different, and also perspective, what happens after the webinar. All right, so the introduction will be about your hosts and then also about working with EduDip. It's actually also for us a new software. We are using it the first time for webinars. Yeah, so it's quite new and you have to learn something. And afterwards, we talk about the objectives of the webinar today. Me, myself, I'm Rene, and I'm responsible for the Herco Academy, also for the tech support, as some of you maybe know. And I've got 10 years experience in water treatment now, and 5 of them in technical training, and I'm also a certified trainer. So yeah, something special.
Yeah, my name is Fergie Fabicious. I'm responsible for product management here in Herco. And I've been working also for a long time, 13 years, in first wastewater treatment and then water treatment. So we're going to share the topics over the next hour.
All right, since 2015, we had about 40 trainings. We also did some trainings before, but 2015 was the year we started counting, actually. And since 2020, because of the actual situation, worldwide crisis, we had to do something different and start with online courses like this. All right, so working with EduDip, it's quite easy software, and it's browser-based. As you might already know, you have the function to use a hand signal on the right side. So there you can just give us a sign, okay, everything is fine, it's not fine, or you're happy, or whatever.
You're going for a coffee break.
Yeah, exactly.
What might be most interesting is if you put the question mark, that means, I don't know, this was just too fast, please repeat, whatever. So if we see lots of question marks popping up, we're going to repeat whatever we're talking about.
Exactly. Or if you just have any questions, feel free to ask them in the chat and we will answer them all.
Okay.
All right, so your microphones and cameras are deactivated, as you might already know, and the webinar will be recorded, and the recording will also be provided afterwards. I think this will be happening with Peter, and he will publish this on the PWG website as the previous webinars. Right.
Okay. Yeah, as we said before, if you have questions, just send them on the chat and we'll be happy to answer everything. If somebody has a very, very specific question, we're going to answer that by mail afterwards. Oh, I see somebody cannot hear us.
On the right side, yeah, I can tell it by this way.
Okay, so we're going to write to
go,
Carla. I'm going to go on.
Yeah,
you want to go back?
Yes.
Right. No, I cannot.
So
So yeah, for everybody, you have the setting buttons, and you can check the settings if you cannot hear us.
Yes.
So try that one out. But I think most people can hear us right now.
Yes, they can.
All right, good. Then let's go on. So the objectives of the webinar, first of all, we want you to get to know the digital learning process. It's also something new for ourselves, really. It's a bit strange to be here in front of the camera and you cannot see the other people. But I think it worked very well for our first webinar in German, and I hope it's going to work as well for you. On the technical side, we want to give you a general understanding of cooling technology. What is it all about? What are the important parameters? We want to give you an overview of the different blowdown controllers that we offer and their properties. And of course, that's the main topic. We want you to show how the new blowdown controller Cooltrol Data works, and we're going to show that with the simulation software. So the idea is for you to be able to know the systems and to provide competent advice for your clients when you want to sell a blowdown controller.
All right, so we will do a survey now, and this will be quite easy survey. And the question is, how much experience do you already have with cooling systems? So do you have none, a bit, average knowledge, or maybe already much knowledge about cooling systems? All right, we already got some answers. Thank you for that. So we just keep waiting for a couple of seconds. Average. All right. All right, so as you can see, we have everything. So the main ones are average and none. So we hope that we can give you some advice, some experience from our side.
We're going to start with the very simple things, and then we're going to ramp up really fast and go into details. So hopefully there will be something for everybody.
All right.
Okay, so we'll start off with cooling systems in general. What is it all about? How does the heat transfer work? There are different methods. What are cycles of concentration and what is blowdown really? And which operational problems do we encounter in cooling towers? Then we're going to have a look at what constitutes a blowdown controller, all the components of the cooling tower and the blowdown controller that can interact. And we're going to also have a look at how conductivity is measured in the blowdown controller. So first of all, cooling systems. In general, a cooling system is always about dissipating heat that comes from industry, let's say, or from a building. So let's say we have an industry, we have machines, and we need to transport the waste heat away from the production. This is done using a medium, which is very often water, because it's relatively easy to use. And the simplest system that is shown here, the most basic one, is one-through cooling. That means water is taken from a water body, let's say a river, can also be a lake, for example, or even groundwater. If necessary, that water is conditioned or treated by filtration, for example, by softening, and is pumped over a heat exchanger where it takes the heat from the machinery of the plant, and then this water is again sent to the water body it came from. This is the simplest method because actually there is no recirculation, so it's not a cooling circuit really, it just goes once through as the name says. It's simple in terms of handling. There is, apart from water treatment, very little machinery really. On the other hand, there is a very large water use. As you can imagine, if it just you use the water once, the water use is in some cases enormous. It has also been a problem about the heat load that goes to the rivers. In the last years, this thermal pollution of rivers has been a topic increasingly, and that's why this system has sometimes been replaced by circuits. It's still a method of choice for, let's say, very large factories that are next to a river, especially power plants. but very often it is at least combined with a cooling tower downstream of the heat exchanger. Okay, now we come to the next system, which is really a cooling circuit. This is open circuit cooling. So the water is pumped over the heat exchanger. The hot water is sprayed on top of a cooling tower. It trickles down, usually over fill material, and this spraying, trickling down gives a large surface between water and air. Air is transported through the cooling tower from bottom up, so it's a countercurrent flow, usually, and it can be either natural draft by geometry of the cooling tower, or it can be induced draft, that means it's pressed or sucked with a fan. With this open circuit cooling, we already have a very large decrease in water consumption because the water is recirculated from the cooling tower. However, there are still some losses, especially due to evaporation and also due to drift, so that droplets are lost from the water cycle. In order to make up for these losses, we need a certain percentage of the recirculation as make-up water. This is a lot less than with one-through cooling, of course. There is also another option, closed-circuit cooling. In this case, you can see already there's no make-up water. This is because the water is now not passing openly or so in contact with the atmosphere through the cooling tower, but it moves in the bundles of a heat exchanger. That means it has no contact with the atmosphere. There is no evaporation, so no water loss, practically no water loss if there is no leakage. On the other hand, the disadvantage is, in this case, you have a less efficient process because evaporation is not available as a form of cooling anymore. So less water loss, but also less efficiency.
What's the most common one of those?
I would definitely say open circuit. That's what we are also going to be talking about. It's the most, let's say, economic methods in many cases. But of course, as we're going to see in the next few slides, it's also a factor is that the water gets polluted because of the evaporation, because of substances from the air.
Okay.
Good. Well, there are different heat transfer methods as well. So there's the wet cooling tower, which pretty much corresponds to the open circuit that we have talked about right now. Water trickles down in the cooling tower. It has the highest performance, as we said, but it has a lot of contact with air with all the consequences. There is also dry cooling. That means it is really only air as a heat transfer medium. So water is not consumed. We have water only in the internal circuit, but water is not evaporated. And there are also combined forms, lots of different variants really, that are usually all summarized under the topic of hybrid cooling. It's a combination of wet and dry cooling, and advantages are there is a lot less cloud formation or almost no cloud formation. In the open cooling tower, of course, there is evaporation, and the water that evaporates is prone to form clouds. So this is the typical cloud you see in the cooling tower of a power plant, let's say, natural draft. Hybrid cooling towers have the advantage that there's a lot less cloud formation, which is good for the microclimate or the people that live next to the plant. And it has also a big advantage, and that's the compact size. It's usually smaller than, let's say, a wet cooling tower. Okay, now we come to the definitions really. Cycles of concentration. We're talking now about an open cooling circuit, and water in the open cooling circuit is constantly evaporating, thereby cooling down also the water that remains in the circuit. Of course, water, when water evaporates, we have only evaporation of chemically clean water, so salts and all the other things that might be in the water will not evaporate. Instead, they accumulate and we have a concentration effect. This is called cycles of concentration, and it's defined as the total dissolved solids of the cooling circuit divided by the total dissolved solids of the makeup water. Usually, we would work with about 3 to 4 cycles of concentration in many applications. Now, you can imagine if we allow the TDS to go up in the circuit, we have a lot of cycles of concentration. That would mean we have a lot less makeup water demand. Brilliant, right? Because less makeup water.
Less waste.
Exactly. So no, you don't have to spend money on the makeup water, but of course, there is a problem. As soon as the salt concentration gets too high, we can have either corrosion or lime scale formation. So the salt concentration in the circuit has to be limited, and this is done with blowdown, also called bleed off. In that case, we remove cooling water via a valve, and makeup water is added to get the original water level again, thereby lowering the content of salt in the circuit. Here you can see which operational problems you can encounter in a system. The main three really are limescale formation, biological growth, and corrosion. Limescale formation clearly is if we have an elevated concentration of calcium, we are going to get the same limescale you get, let's say, in the kitchen when you heat up water in a pot. This is a problem because of reduction of efficiency, obviously, but also the weight of the fill material, for example. So you can get even a compression or destruction of the fill material if there's too much limescale formation. Solution or measures taken to avoid this is softening of the makeup water, for example, and in very many cases, the dosing of hardness stabilizer to the circuit. Biological growth is simply because there are ideal conditions really in a heat exchanger, in a cooling tower for microorganisms. We have elevated temperature. Very often there is some light in there as well, and there are nutrients and salts in the water. So this leads to the formation either of a biofilm, growth of algae, as seen in this nice picture. When you see it in the cooling tower, it doesn't look that nice anymore. And of course, there can be health hazard, especially with certain microorganisms. Legionella, you probably heard of them.
Yes.
Measures, very simple, usually it's dosing of a biocide. It can also be disinfection with UV, but the most common method is biocide dosing. Corrosion can be a problem if there is an elevated concentration of chlorine, of sulfate, if the pH is out of a, let's say, more or less neutral range. And this results in leaks, so that there are costs for repairs, there is downtime of the whole system.
So when you're talking about neutral range, what range do you actually mean? Is it like 5 or 2 or?
Well, 2 for sure not, that's clear. So we would look for something around 7. I mean, very often maybe not exactly, but let's say 6 to 8 might be a good range.
Okay.
But as soon as we get a higher concentration of salts, we can easily get into a different range.
Okay.
The possibility, of course, to adjust this is 1, to adjust the pH, and 2, which is done very often, which we're going to talk about later also, is the dosing of corrosion inhibitor.
Okay.
Okay. Now we're going to check if you all have listened carefully or if you're already asleep. So there's the next survey.
Yes. So basically, we want to ask you, what's the advantage of a hybrid cooling tower? So you remember there was like the water cooling tower, then the air cooling tower, and then the mixture of both. So what could it be? The highest heat performance, no water consumption, or the no cloud formation, and also the compact size? Wow.
Wow, that's
perfect. Wow.
Very good.
Really good.
So we have
100%.
I have to say, this result is really good, and that's a lot better than the German course. So.
Yes.
Good.
All right, let's go back.
So after this, we're going to go on with the components of a blowdown controller. So we're gonna start with the cooling tower itself. That's what you see here. The cooling tower, where water is sprayed over nozzles. You can see that on top, and water trickles down through the cooling tower. It gets collected in the cooling tower basin that is shown here. And then we have a recirculation pump, which is the number 2, which pumps the water back up to the top, where it is again passing the nozzles and going to trickle down. As we have evaporation and drift, so water losses in an open circuit system, we need makeup water, which is shown here in light blue. The makeup water line has a flow meter usually, shown with the number 3 here. And the makeup water is of course regulated for the level of water in the cooling tower basin. Now we show you really parts of the blowdown controller. First of all, in order to control the blowdown or the bleed off, we need a parameter. We use conductivity in this case because it's easier to measure than total dissolved solids, and we want an online measurement, obviously. We have a bypass line from the recirculation pump going out on the pressure side of the recirculation pump and coming back on the suction side. Since there is a pressure drop over this bypass line, we ensure that there's always enough flow so that the measurement is really correct and we don't measure in stagnant water. The measurement is shown here with the number 4, quality measurement, conductivity. And we have also here the line in orange, which is really the blowdown. You can see with the number 5, the blowdown valve, motorized valve, which is activated or deactivated by the blowdown controller. And you see there is also usually a flow measurement on the blowdown line so that you know how much water has been used or has been used. So the final components of the system really are the dosing systems, here number 7 and 8. Usually there is one volume proportional dosing. This is the corrosion inhibitor. This dosing is done proportional to the makeup water that is coming in. So it's controlled by the makeup water flow meter signal. And number 8 is the time proportional dosing or time controlled dosing. This is the biocide. This is not controlled by the makeup water flow because even if the cooling tower doesn't use makeup water or is in standby right now, is not being used, we still need to dose biocide in order to avoid biological growth. This is dosed directly in the recirculation line, and it is controlled with a timer. You can see here in the gray square what is really the blowdown controller scope of supply. So the blowdown controller includes the control system and this part of the piping that is shown here in the gray square, which is the measurement of the conductivity and the blowdown valve.
But you can still buy dosing pumps.
Of course. So we also sell other, as Renee said, that's very true. We also sell other components. For example, the flow meters, number 6 and number 3, that can also be bought. This is usually then separately. We sell the dosing pumps. We even sell different types of the blowdown controller with or without the motorized blowdown valve, if it has been installed in a different location, but we'll come to that a bit later. Good. About conductivity, one more point before we wrap up the theoretical part. Conductivity can be measured in 2 ways, conductive or inductive. Our blowdown controllers, most of them work with both types of sensors. Conductive is the most common type and the more basic one, let's say. It requires several measurement ranges for low conductivity and high. And most important, it has a direct contact of electrode and medium. That means it's very useful for slightly polluted water, but it can have problems because of the direct contact once the water is really highly polluted, has a lot of TDS, for example. In that case, an inductive measurement can be a better option. Here we have no polarization effect due to higher ion concentrations, and we can accept the higher cooling water pollution in general. This sensor, however, is then a bit more expensive, but there is also very little need for maintenance. So these are the two options that are offered. Good, that was basically the theoretical part, and now we're going to come to the part of our blowdown controllers, where we're going to show you which types of controllers we offer and which are adequate for which system, let's say. We start with our simplest or oldest blowdown controller, let's say the LFCC. Then we go to the classical version, the Cooltrol, and our new one, the Cooltrol Data. And we're going to show you also which different versions of controllers there are. Okay, LFCC, that's the simple one. That's historically speaking because, first of all, the first blowdown controllers, not just from us, but in general in the industry, were mainly concerned with the main function. That means the blowdown interlock. Okay, when can I start the blowdown? When the conductivity is over a certain set point. But there was no dosing control. That means this control of the two different dosing systems, volume and time proportional, is not included yet. So this is the most basic version. But if there's a simple cooling system, can still be the most adequate version.
Yeah. And I also want to show you something from the technical part side. So actually on the controller itself, you know, with the other controllers, you always have buttons where you can set up in menus something, but this one is really, really simple. So you see the red dot, there's just a switch that you can switch up or down for choosing set points and also for calibration, and that's it. So you have basically one switch for all the settings.
So this
is
is
quite simple.
Very simple system. Of course, this is also the most cost-effective system, let's say. We have very few inputs and outputs here. One input is, of course, the conductivity meter, obviously. And it's worth to mention also that in this blowdown controller, there's only a conductive measurement available. In our other ranges, we have conductive and inductive measurements. There's as output, of course, the signal for the blowdown valve to open or shut. There's a fault that is shown here, I think, with an LED.
Yes.
And the conductivity value can also be sent as an output for 20 milliamperes to, let's say, a central control system. Now, the next one is our classical Cooltrol controller. This has the blowdown interlock. It has a forced blowdown or pre-blowdown, which is a blowdown done before dosing of biocide, because some biocides, depending on the type of biocide, can increase the conductivity quite a bit because of the concentration of, let's say, active substances.
What's a blowdown interlock? I don't think we explained this already.
Okay, we're to the most basic parts. Yeah. Okay, so you can have a blowdown. So you will start the blowdown usually when the conductivity goes over a certain value. However, when you dose biocide into the system, there's a legal requirement not to immediately discharge this biocide into the wastewater, because it's going to damage microorganisms, let's say later in the wastewater treatment or in the river, wherever you send it to. In this case, if you dose biocide, a blowdown is not allowed, even if the conductivity is higher than the value that we have set as a set point. And that means there is an interlock so that the blowdown valve is not going to open when biocide is dosed. To prevent this, or to already lower the conductivity, we use this forced blowdown, which is the second point, so that we can already reduce the conductivity before we start with the biocide dosing. We have here included already the control of the two dosing pumps. That means we have a timer included for the biocide dosing, and we get the signal from the flow meter on the makeup water line. And with this signal, that is sent to the blowdown controller, and that is going to be used in the blowdown controller for control of the volume control dosing, i.e. corrosion inhibitor in this case. The hardness related chemical. We have more inputs and outputs here already. So we have the input from the conductivity meter, which can be conductive or inductive. We have the inputs from the two water meters on the makeup water line and on the blowdown line. We have signals if the dosing tanks of these two remote switch off of the plant from the central system of the client, let's say, and general input value. As output, we have, of course, the signal for the blowdown valve, conductivity value, which can be sent to the central system of the client, and the two signals for dosing, on, off, and the release of the recirculation pump. This is necessary when normally the recirculation pump is controlled by the general cooling tower control, let's say, of the client. But if we want to dose biocide, we need to have the recirculation pump on because the dosing is done in the recirculation pump pressure side. So obviously, then we have to give a signal to the recirculation pump to start operating. Design compared to the old one, I think it looks a lot better, right?
Yes, of course.
And the main feature, the main difference is that we are logging the data now on a micro SD card. That's where the name comes from too. This is because requirements in Germany and maybe other countries too, most probably, require the operators in most cases to log the data from the cooling tower system. This is, for example, also because in some cases there have been Legionella outbreaks because of cooling towers that had been badly maintained. So this should be avoided in future, and that's why people have to log their data as well. We have, apart from the data logging, the functions that you will know from the Cooltrol controller already. So we have the blowdown interlock, not to have any loss of biocide directly to the wastewater. We have the forced blowdown or pre-blowdown, and we control two dosing pumps. A difference to the previous controller is also that with Cooltrol, you could set the dosing pumps like you want. So let's say 2 times temp control, 2 times volume control, which is nice because of the flexibility, but also problematic if the operator, let's say, confuses the two dosings.
Yes, of course.
So in this case, we have a fixed setting really. One dosing is definitely time controlled, biocide 1, and the other one is definitely volume controlled, corrosion inhibitor. We also have the release of the recirculation pump as in the Cooltrol, and we have pretty much similar inputs and outputs, but we have a few more outputs that are quite useful. So instead of only fault, we have here warning and fault. So that can be, you can already program something that is, okay, an indication something's wrong, but maybe only, okay, the operator needs to know and he has to change something, let's say.
Yeah, fill new chemicals inside for the dosing pumps. And, yeah.
Exactly. And there's the fault, which really means something's really wrong and the system has to be checked. We have additionally also operation signal. So one of the 4 main functions can be sent out. We'll show that a bit later now. Here we show the main differences condensed compared to the Cooltrol. Logging of data is new. So this we have in the Cooltrol data. We have the color of the display in the old Cooltrol. I'm just going to go back. You see you have LEDs there, so it's not that visible.
Yeah,
maybe you can show it.
It's like status LEDs. It's hard to see on a small picture, but it's like for operation, dosing 1, dosing 2, and everything. So it's basically just LEDs.
Okay, and here you have really a color of the display. So warning will be orange and fault will be red. And since it's the whole display, it's really very, really good visibility.
Yes.
We have the operation signal, as I said. So for blowdown, for release of the dosing pump and the 2 dosing options, we can put out a signal to say on or off, to log it also in the central system. There's no risk, as we said, to confuse the different dosing stations due to the fixed allocation of time and volume control. And we have a new blowdown valve, which is currently as closed. That means if the conditions on site are such that the basin of the cooling tower could run dry because everything runs out through the blowdown valve, then you are safe in case of emergency, let's say power failure, because the blowdown valve will always close when it's currently. It's also important to know, if you have used the old Cooltrol, that the Cooltrol data has been developed on a new basis. So this is also with a new development partner. It's a different system. And the structure of the menus is different. We're going to see that when René shows you the simulation. Yeah. And the connectivity sensors is also different than the old sensors. So if you have a look in our catalog, you will also see that there are sensors for Cooltrol data and sensors for Cooltrol.
So you can't use the existing ones.
Exactly. We offer different models, not just of the Cooltrol data, but of all of the controllers, basically. So we have Cooltrol and Cooltrol data either with conductive connectivity measurement or with inductive. We offer the bypass measuring section. That means the controller minus the blowdown valve. If the blowdown valve has to be put in a different location and it cannot be installed on this plate with all the other controller components, it can be useful to order only this bypass measuring section, which includes 2 manual valves plus the connectivity measurement, and then to install the blowdown valve where it has to be installed locally and connected from there to the controller. And of course, we also offer just the controller itself for clients who would like to assemble all the accessories themselves and then to have only the control system from us. As René said before, we include all the accessories. Let's say you have to replace sensors, cables, fittings. We have here protection, weatherproof casing, and we offer the blowdown valves, dosing stations, water meters, and so on.
Yeah, this is the weatherproof casing.
Exactly, and this works for all the different controllers. Okay, so this is basically all the things we offer in the range of blowdown controllers. And now René is going to guide you through. Oh no, we're going to ask something first.
Not so fast.
Too fast.
So we actually have a survey. So just again for you, if you have listened, so we are checking what's the coolest thing. What do you think is the coolest thing about the new Cooltrol data? All right. So we have the logging function, the new color display with the status that you can see from far distance, or the universal output where you can assign manually fixed allocation of the dosing pumps, or the new design. All right. Okay. So far we have the universal output. Logging function is rising rapidly.
Right. Okay, looks relatively clear.
So we see clearly the same like in Germany. It's the logging function because many customers demand this, and so this is basically why we developed the new controller, not the other parts. All right, thank you.
Okay, and now I hand over to René for really an overview and showing you how to work with a Cooltrol data.
Yes, all right. So on the right side, you can see already the controller itself. So we have like 4 buttons. It's escape as usually, which is for navigation through the menu to get out of the menus, and also to acknowledge faults, like with all our other controllers. Then we only have the up and down button to adjust values, and the enter button actually to confirm anything. On the button, which is also, I think, new. Oh, no, it's not new. It's also in the other control, but it's again on the display. So basically we have the PNID with all the components. So you get the idea when you're standing right in front, okay, which one is, or what is this component and what is it doing. All right, so we will talk about now about the menu structure and operation of the controller, and also the data logging. How is it looking? What is it doing? And then I will show you a simulation tool, which I can hand over to you after the webinar, where you can actually test yourself the system and just play around a bit.
Yeah, right. So that's very useful just to get to know it if you haven't worked with it before, especially.
All right, so here again we have an overview about different Cooltrol data. So it's always good to know what those shortcuts mean. So it's Cooltrol data plus K. K unfortunately is German for conductive. So normally it should be C in English, but it's called K. Right, so then we have KBP for the bypass system. So you can already see here's the valve on the left side. On this one, there's no valve actually on the plate. So this is with the not local blowdown valve, so you can install it anywhere you want. So then we have the I for inductive, so just a different measurement. You see it basically really fast. So the conductive looks quite small, and the inductive one has a huge box on it.
Why is that?
So basically, it's just because it has more wires. So conductive is just like a 2-wire system with an isolation, and inductive has like, I think, 7 wires or something like this. And you have to, connect those everywhere on the small plugs. So it's a really bigger box for more cables.
Makes sense.
All right, on the right side again, bypass. So no valve on itself. And that's basically the differences of the controllers. Not the controllers, the plates. All right, so menu structure of the Cooltrol is like for settings and everything, the access codes are as usual. So you maybe already know 1, 2, 3, 4, 3, 4, 5, 6. So it's really simple, and we will check the settings later in the simulation tool. All right, so we have different operation displays. So you always see on the middle the actual operation or the information stage you're at. So for this one, it would be proportional dosing. And then you see, all right, if you're actually operating the system. So this one is standby, actually, the time, and also the actual flow where you dose to. Then for time dosing, you see we have also the state, and in the middle you have the dosing time left and the lock left. You remember the lock is for keeping the chemicals inside, and then also how long we are dosing, how long we are locking. And that's basically all information you get there. On the right side, you see the bleed off information. So basically the temperature and the conductivity, and also what you're actually doing. So circulation, or if you're taking water out of the system. So in the next one, you see the information about the bleed off discharge. Again, you see the valve, and then you see the flow that's actually going to the drain that is also locked. So you know how much water you have wasted. All right, then for the circulation pump, it's quite easy. It's only the pump. So it's white when it's doing nothing, and it's black when it's actually doing something. So it's just the status, go or stop. And on the right side, we have also the operation time and system enable. That's like the external contact to tell the system to start or stop. Right.
Too fast.
Too fast. All right, so here you see the logging file. So it's actually in German, but it is like that. All right, so we have the date and the time. Then also ID. ID is for actually if there's nothing, it's a D, so this is normal operation. If there is a fault, then you see it's A plus, so the fault comes. And if you acknowledge the fault afterwards, it's A minus, so this means the fault goes. So, all right, then we have the state of the circulation pump, normally in English, and also the status of the dosing pump. So for the proportional dosing, no, time dosing, sorry.
In that case.
But anyway, you don't understand it, this is German. All right, so
you never know.
so then we have the actually the time dosing mode. So this is a really huge difference to the old Cooltrol, because it's now not called manual or automatic or anything. It's called process controlled or on and off. So it's basically only those three left now. This is also for a better understanding, so it's easier to handle for the customers. Then we also have the proportional dosing, only the state on or off, then the impulses of the flow meters for the different ones, feed, the drain, and also here the state of the blowdown valve, then the connectivity, inductive or conductive, either which probe is connected, and then the temperature of the system. So it gives you all the information you actually need from the system. So now I have to share my screen, so this can take some seconds. So
Okay, now we're going to the simulation system.
Exactly.
So that's probably interesting because you really see how the working with the system feels.
Yes, so if you have any questions in the meantime, we got some seconds because this always takes a bit. So just post them into the chat, or if you feel good, then just post a thumbs up, whatever you want.
At least we haven't got any question marks until now, but
Alright, so,
now we go.
alright, so I think
Takes a bit. Can you see that already?
like we said, it's the first time we are using the software, so
Now I
So
think now it should work
technically-
for everybody.
yeah, so it takes a bit. It's new for us, so
Trial and error.
all right, exactly. So basically here in this display, you see all the information you have from the system. So on the left side, we have the two dosing pumps and with also the tank. So you see the status actually, so if it's filled or not, right here. So in the simulation, we can now simulate, okay, that this one is empty. So normally you see on the right side now that the screen turns red. So this is one of the new things with the Cooltrol data. So you actually see it far from distance that there's something wrong with the system. So, all right, so like I said before, it's like usual with acknowledge. You can acknowledge the fault, of course, if it's gone. If it's not gone, it will remain there. So then on the right side of the dosing pumps, you have all the information for the actual blowdown, and like the flows and also the conductivity, temperature, and the actual flow. So I want to go directly into the controller itself. So in the controller inside, let's just go out of this. So there we have the, how is it called in English? Rectifier, I think. It's, you know, for seeing the faults.
The fault menu or?
Yeah. All right, so inside the menu, we can choose the language. Also a difference, we only have, let's go with the password. So we only have German and English. So this might be a disadvantage for some of the guys from Spain, because I think we had Spanish before. All right, so inside the settings, we have the information then for all the different. We have a question. Can we write information from the doping systems? The chemical is going out, but the alarm that it's home, but earlier that the level is low.
Do you mean maybe not that it's completely empty, but like a pre-alarm?
You know that basically on the pumps we are using, those are mainly Grundfos dosing pumps, and they always have two levels of the dosing pump. So it depends on the dosing pump you're using from Grundfos. So they have mostly like two levels. So there's a pre-alarm and then the alarm for those. And you can set this up actually in the pump itself and say, okay, give out the output on the pre-warning or on the alarm. So it's actually a setting that you can do inside of the dosing pump. So it's not really in the control itself.
But we have one signal from the pump, so of course either you choose the pre-alarm, then it's a bit earlier,
Yes.
and you know you still have some time, or you choose really the alarm, then you really have to do something when you get the signal.
Yes. All right. Thank you. All right. So, like I said, bleed off. There's all the information for the actual bleed off process. So we can say inside how we want to control it. This is the thing I told you that is new. It's you can either say process controlled, off, or on. And previously it was automatic, off, on, manual, or anything. So it's kind of reduced a bit, so it's more simple to understand. And we can say when we want to start the bleed off. So this is actually our working point where the valve opens and drains water from the system. Then we have the hysteresis. So hysteresis means that we don't get into a flicker operation. So it means we have a bit of balancing. So this would mean we bleed off until 1400 and then we get fresh water in. All right, so for the pre-bleeding, so this is basically for if you're dosing chemicals. So we start earlier. So if there's like 800 in the system, then you don't have to pre-bleed before you dose your chemicals. So this is just a factor inside. And you can also set this up that you say we have a minimum duration. So we say, okay, before we go into operation, it doesn't matter how much conductivity we have. We just say, all right, let's bleed off for 10 minutes to be safe during the bleed off process. Then of course we can choose the conductivity sensor. So what sensor type it is, conductive, inductive, and also set up limits for it. So basically in the limits, you only have the information if the sensor is broken or there is some kind of short circuit, anything inside that tells us that the sensor is defect actually.
So you set the limits that to values that couldn't occur in normal operation.
Exactly,
right?
That's it. Yes. So you see, min warning is like 50 microsiemens. So this can't happen normally with normal water, with tap water with like 500 microsiemens. And then also the max warning. We have to differ this. There's a warning actually, and then alarm. And yeah, and we can also say, okay, what we want to do. So do we want to continue to operate the system or do we want to stop it? So this is always depending on the application that's actually afterwards. Right, so if we continue, we have all the information for the valve control. So this is actually for telling if it's normally open, normally closed. For the flow sensors, we have the information about how much impulses we are having. So this is basically interesting for you if you're using your own flow meters inside. So we get the correct information from the flow sensor, from the flow sensor. Mm-hmm. All right, so for proportional dosing and time dosing, this is just, again, the flow information for proportional dosing, and for time dosing, you basically set up, okay, when we want to start the biocide, and yeah. So we go down here, so you see we have 4 different starting times, so we can say, okay, we want to do one in the morning, one in the after lunch, one in the evening, or whatever, and can say when it should start, and then also on which weekday. So we can say, okay, Monday, Wednesday, and Friday we do something different than Tuesday and Thursday. So you're really flexible with this one. All right, so system enabled is just the external contact to actually start and stop the system. And this is just information about, okay, is it normally closed or normally open contact? So just for configuring the system. So like I said, we will give you all this simulation tool via mail. If you're interested, just send us a mail. and then you can handle this yourself, play a bit around. And if any questions are popping, just send a mail or call me, whatever you prefer, and then we will talk about it. And you also get the documentation for this, so with all the information about the actual Cooltrol data.
Exactly.
Yes.
Yeah.
So this is also the part where we jump back into our presentation. So
Exactly. So yeah, you will receive a link, like René said, also to evaluate. We would be very happy to hear from you how you liked it.
yes.
We hope we liked it, of course. Yeah, like we said, it's our first English webinar. It's our second one only, but we want to have a lot of webinars, really, especially for introductory topics, but also for specific topics. And since this whole situation with Corona, but nobody knows how long it's going to stay like this, we think it's also going to be very useful for you, so that we can provide some information and people don't have to travel. We're already planning our next webinar, actually, in 2 weeks. It's going to be about nanofiltration, and you should hopefully receive an invitation in the next few days,
Yes.
probably today or tomorrow. Yeah, if you have I think we have a question in the evaluation about
Can be.
topics.
I don't know.
But if you have specific topics that you would like to have in a webinar, we would be very happy if you just drop us a line via mail
Exactly.
or write about it in the evaluation.
All right. So we got 3 minutes left. So if you have any questions, then feel free to ask. I think we also got some survey for the... No, we don't have anything left. Yeah.
Yeah,
All
I
right.
can do
So
a survey next time about the moderators.
yeah, exactly. So actually, if you don't have anything left, just pop your questions and we will stay another 3 minutes for you. And if you just say, yeah, it's perfect, then let us know.
We're also happy about that. Yeah, let's see if there's anything. Yeah, otherwise, we hope you liked it. We hope you all stay safe, stay healthy.
And you get some new contacts. Maybe you try out something new, or you learned a bit more for the experienced guys for the cooling systems.
Exactly. We have a question about if we design or manufacture the electronics internally. The electronics, no, that's why we are a partner for the development. So the electronic part comes from a partner, was also like that for the previous controls. We do manufacture the entire system, so that we connect the controller, put the piping, the measurement, the assembly. So we do that.
So we basically ask suppliers with our demands to program these controllers and also build them. We don't build them ourselves. We just tell them what we want, and they do this, and then we control it, and then we change some things again. And so it's basically like an
but it's a partnership, really. I think we put the requirements, and of course we're not specialized in electronics, so they do that. And we're specialized in the process side, let's say.
Exactly.
Yeah.
And manufacturing membranes.
Of course.
Membrane systems.
The plants, exactly.
Yeah.
Yeah, so thank you all.
Enjoy the rest of the week. It's not long to go for the weekend.
Yeah, have a really nice weekend.
Yeah.
And hopefully see you soon in the next webinar.
All right. Goodbye.
Okay. Goodbye.